Hello, today we're going to go over the CDG 7000-75-10 system used for magnetic testing for medical requirements and generally for the IEC 61004-39 standard for close proximity products. The system consists of the CDG 7000 generator and software to control the unit. The generator itself has everything to run the test, a signal generator with modulation capability, the 75 watt amplifier from 10 kilohertz to 230 megahertz, and measurement capability for forward and reverse power, as well as measuring the field of the coil. This system also has the added benefit of being used as a conducted immunity system for 61004-6, which obviously different accessories would be needed for that, but the system has dual purpose. With a turnkey package, you also get the loops, the matching networks, and the loop sensors. So here we have two different sets covering two different frequency ranges. So this is a low frequency unit, it's a little bit bigger than the higher frequency. You have the matching network. This is a capacitor used for the higher frequency that So here we have the front panel of the CDG 7000. It's pretty straightforward how it works. You have a ground connection, needs to be tied to your ground. The RF in for magnetic testing, this would be connected to your loop sensor, and your RF out. And for magnetic testing, we go to your loop emitter. And of course your on-off button. Some indications when your RF out is on, this will light up. The system's ready to test. Green light. You have an interlock function which you can connect through the back. And fault. Something goes wrong with the generator, such as an overload. Alright, so we're going to go over how to set up and use the software for doing the magnetic testing for the medical requirements. To install the software, I've already had it installed on this computer, so I'm not going to go through that again, but I'm going to explain a little bit. The install wizard is on the memory stick that's supplied with the system. When I installed it on this computer, it did take 3 times to get to fully install. This computer was sitting in storage for a number of months, so it had to also go through a number of Windows updates, so that probably contributed to that. But if it doesn't install, if the Helia test software doesn't install, just reboot and try it again, and eventually everything will come through. You connect the computer to the generator with USB or Ethernet. USB is a very simple setup. It really auto discovers the generator pretty easily. With Ethernet, there could be some more setup to align the IP addresses. So what I would suggest is to get everything working on USB first, and if you want to use Ethernet, once you have everything established and working, then work on setting up the Ethernet, and we can help you out with getting that set up. There is a USB dongle that allows the Helia software to work, so make sure that is connected to your computer as well. We'll boot up the software, and here you go. You have the introductory screen, and we have new tests. All right, that's how you would select and create tests. Generator has 2 options. This is test level. in direct mode. Direct mode really can't be used for magnetic testing, but it can be for conductive immunity testing. And then test level is what's used to set your test levels. For conductive immunity, it would be when you're running your calibration with your CDNs or EM clamp. In this case, it would be with our loop antennas. And on the right side, you have an about screen to go through. You can see what your licensing is and that kind of information. Settings, and here you can update some settings, show hints, correction table, delimiter. It's semicolon is standard, and that's what the files that's supplied with the unit come in. So you can change this to have a little more margin. Let's put that put something on there for sure. X and input folder. So you can select what your default folders are. If you don't select this, it'll just go to whatever you use last. Now you can put in company information. This will be populated when you do reports. So you can add and update this for different users and generate reports. If you need to change the max output level, you can change that, and that's probably more useful if you had an external amplifier for additional or testing beyond the internal amplifier's capabilities. Keep signal while paused. So if you pause the test, it'll keep the signal on. So if you're troubleshooting stuff like that, you can do some diagnostic work on your product, or you can turn it off where it'll turn the signal off when you pause the test. Search device. So this just runs through a thing and pings and see if it finds any devices. One of the nice things with this unit, it actually will control and work with other devices that work on Skippy generic protocols, and you can get measurements back from, say, a DVM or something like that to monitor products, and you can add some additional capabilities into that. There's also some analog I/O inputs on the back of the generator you can monitor as well. So in order to start testing for the IEC 60601-1-2 medical requirements, where there's 3 individual test frequencies to test to, we will begin that routine and show you how to set it up. So it does require a setup initially for the user. So we need to set the level of the test. So we come in here, click on level setting, and then we have to go into type, change that from voltage to mag field, and then it changes it set up to that. So we're going to start off right here. We have the lower frequency loop. We'll start with the first frequency, which is 30 kilohertz, and that test level for 30 kilohertz is 8 amps per meter. I'm going to type in 8, and that gives it an amps per meter. And the level setting is basically just the amps per meter in dB and amps per meter. If you have that, you can select, you could enter that in, and it would change that. So you can put the value in either or. But the device itself uses the dB value for level setting. Then we need to set up the frequency range we're going to test to. Now we need to do a sweep. In this drop down, you do have the ability to do a linear sweep, a logarithmic sweep, and a single shot sweep, or single shot. So you really can't do a single shot. We need to have multiple points across the frequency range. So we can either check linear or logarithmic. we need to have at least a 10 kilohertz bandwidth of the sweep over, so you want to center the test frequency inside that sweep. So we're doing 30 kilohertz, so we can do 0.02, so that'd be 20 kilohertz to 0.04, 40 kilohertz. And let's do a bunch of steps in there, make it a little more exciting for the, it doesn't really matter, it doesn't change much over that range at all, but we can see what's happening here. 0.0. Yeah, so we have a 0.1 megahertz linear step. Then we have to select our transducer, which will be our measurement device. So here we have our loop sensor. This is the loop sensor 040, and this is for the lower frequency, and that goes on here, and you gotta push it on there, completely on. In our setup, we have our output of our generator going to our matching network, and matching network is coming up into the radiating loop. The radiating loop model number is RL120. Just select the correct loop sensor, open, and now we can run our test. And then down here, you can see our RF is out. And it's now it's going through. You can see some action here. This is our test level, it's going through, and then here's our forward power. And it's jumping through, and here it's showing what frequency we're at and the test level. Now we're done. So we have our flat response and our output. And as you can see here, it's 25.1 to 25.4. It's very tight. If you want to back that out, you can use the scroll mouse to zoom out, zoom in. You turn the automatics back on. You can do that. It scrolls up and down. You can also come in here and edit that. So you can set your Y axis sampling rate. You can do a lot more options in here to change how that graph looks. We have to come in after we've done the test run. You have to save our coupling device name, and we need to save it as something that's useful for us, so we can pull it back up. So this is the RL120 8 amps per meter, 30 kilohertz, LS 040 is for the monitoring loop, and you can put a date in there. So we'll say we're 5/21/22. Everything's saved there. We can also create a report. The report is put out these graphs and the settings we had into a PDF format. If you want to run the test again, you can clear the graphs. You can just click on this and it clears everything, and we can run it again. We'll go back and then show how a test is run with that file we just generated. So here we go, and go into sweep. Make that bigger. And change the test again to magnetic field. So we're moving 4 power. We're going to measure 8 amps per meter. So here, instead of doing a sweep, we can do a single shock now. So we want to do 30 kilohertz. Oh no, since it's megahertz, we can go 0.3. And then we can change our dwell time to whatever suits the EUT response time. We also can set a modulation. And at this first frequency, there is no modulation that's normally used in the standard. So it's a CW signal, so we can keep modulation off. What we do need to do is select the test run, or the coupling unit we just ran, which is actually on the bottom here. So I have some other ones in here, but you can see the name we just did, and there it goes, disappears. We select that. We have that all set. So up in here it shows a yellow icon for the coupling device, which is also shown in the schema here. So we have some yellow ones. So yellow means that we're in the right frequency range and the right test level. If you hover over the top of this, it says coupling device compatibility, different frequency definitions, extrapolation necessary. So since we did a sweep in the calibration or the level setting, it's not exactly on 30 kilohertz for the test point, so it's going to extrapolate a little bit. Again, I mean the error there is very minor, and we can run that test. So it's going to run and at one frequency for 3 seconds, and then it's done. Now we don't really need a loop sensor on there, that wouldn't be there. This would be placed for the product you're testing, so you can use this jig and position that to the height you want to test your product. You would have to window your product on all surfaces to test what's going on for each run. So you can pretty much position this, hit run, and it runs the test. It says here. So we have the 4 power, which shows that. The 4 power, and put it on automatic here, and then we can. So there's only 1 point. It only shows 1 point here, and the same thing here. It only shows the 1 point there. So there and there, 4 power. And you can swap between these two. So this button here swaps, puts one on front of the other, and so you have the option of looking at one over another one. So we have this run. We can save this sequence test. So we say this is 30 kilohertz. Well, actually, let's do this a different way. So let's call this IEC 60601-1-2, 30 kilohertz. And we'll put the level on there too, 8. Yeah. And we'll save that. Make sure you want to save. Yep. And up here you have some options here. You can save. You save the sequence. You can save the whole as a complete sequence. What this does, it saves not just the test run, but also the data. We can create a report from the data. We can remove the graphs and do another test. So if we run a test again, it's just one. So it's very short. You also have the ability to save the recording. So recording is the data. So you can re-pull the data out. It uses the same name. If we do a full sequence, it'll ask for a different name. And report. So it uses the same name. Creates that. That goes away. So if we go back in our file menu, bring up that report. Here's some files. Coming up. Come on. There we go. And here, you have the test, any information you had entered into the user information. You have the sweep, what was done. Forward power, target level. And there you have the report. So you also have a freedom to customize your testing. You can add channels. So you can add temperature into your test. The unit itself can do that. You can do UT monitoring from the unit. There's I/O inputs on the back port connection. You can look at the reverse power. So there's more options here you can add into. And also, if you had anything like before that was Skippy controlled through protocol, the software will go out there and search and see what's there, and that would also show up in your channels menu here. So it shows like a DVM or something like that. Coupling devices, which we've shown, you have to pull in your level setting coupling device, and tests. Tests here will be all the tests that you've run previously. You could come in here and actually run a sequence of tests and bring in a bunch of tests and run them in sequence. We go back out to the beginning thing. So this is the saved one we just ran. So now that we have this saved, we don't have to enter all the data again. We just click on that, and then everything comes in here pre-populated. All right. So if we did modulation, that'd be pre-populated there. We don't have to re-enter it, so that saves a step in the future. So now we need to set up a test for the next frequency, which is 134.2 kilohertz. So we're going to do a level setting. We're going to set up the test and just make this a little higher. No, that's a little too high outside the picture, so you can see it. Put the loop sensor on there. So for this frequency, there is a capacitor network. So the capacitor network offers a much lower power need to reach the level for the 134.2 kilohertz. Instead of, I think it's around 60 watts, I think it is. It only requires around 20 watts when the capacitor is used. Now, the unit here has enough power to do the testing without the capacitor, but you want to use it because you don't want to push the unit into saturation. And then, you know, if we can make the testing a lot more efficient, that's always better. So we're going to come in here again, magnetic field test. The test level for this test is, looking at my cheat sheet here, is 65 amps per read. 65. We'll switch this to linear. We're gonna go from there we go. So we're going from 30 kilohertz to 130 kilohertz to 140 kilohertz. And then again we'll do add a 0 in there. We'll do a smaller step. Import the loop sensor again. And then we're ready to go. So the level setting, no modulations are used for the level setting. It's a straight CW signal. But when we go to the test for this particular frequency, we'll have to add a modulation. And here, so it's getting up higher levels. We're gonna, so we go 96.26 is our target. No, we don't see it because these were not on auto. Alright, let's rerun it again so we get to see it in action. There we go. So as it's running, we were able to see the generator level and the frequency, but now it's done, it resets back. Everything gets turned off. We have to save this. Into a reusable format, so RL 120. Since we use a cat, I'll put that in there as well. 65 amps per meter. And 134.2 kilohertz. This is a test frequency we're shooting for. We'll save that. We'll go back, go to sweep, change magnetic field, testing to 65 amps per meter. Switch to a single shot. 134.2 kilohertz. So leave it at 0.1324. Dyslexia kicking in. Alright, and here we do want a modulation. We want a pulse modulation. So we want that. We want the frequency to be 2.1 kilohertz. 2.1. And the duty cycle is 50%. And we can change this to, say, 3 seconds dwell time. That should be everything. So everything should be automatic. Let's check this one. So, yeah, it's automatic. Let's keep the target over there. And then we need to get the right coupling device, which is going to be the last one we ran, but let's just double check that. So right there. So the last one we ran, automatic gets put in there. And we can just go and run the test. Does it 3 seconds, and the test is over. And there we go. Now we can save this test sequence. Similar to what we did before, so I would say IEC 60601-1-2 frequency was 134.2 kilohertz. And the test level is 65 amps per meter with modulation. So I didn't put a P in on that. And we'll save that. You sure? Yes, of course, I'm sure. And there we go. So we have it saved. Again, you can do a test report from that. Oh, did that this time, so we can go back here. Oh, but it saved it a second. We can go ahead and error. And there we go, all the information for the test. If we go back to the home screen, now our test is there. So we have a 30 kilohertz and 134 kilohertz. So when we redo these tests, we can just pull this up without having to reset up all the parameters. Now we can do a level setting with a new run for each day, and then pull that up when we run the test. So that next we have the last frequency, which is a new loop and test setup. So we'll get set for that. We'll first do the level setting. For that, we'll disconnect. This setup. And then bring in our other stuff. So this has a different network input, and a loop sensor, different loop sensor. Connect that in, connect that to the RF in. Here we got, make sure everything's set up right. RF out, comes out, goes into our matching network. So our matching network is for the RL100. And so this matching network is for the 60601-1-2. And this loop actually has another matching network that can be purchased for doing the IEC 61000 4.39. Those levels are lower. They don't require as good as a matching network for the 13.56 megahertz that we're testing to. Okay. So we need to first come in here and change it to magnetic field. The field is 7.5 amps per meter. We're going to do linear steps. Go from 13 megahertz, 14 megahertz. So we can do bigger steps here, and we'll keep it at 10 kilohertz. We have set normal, and we have to put the transducer table. So the new transducer is the LS040-1. Open that up, and we're ready to do a run here. Now it's bringing up the test level, forward power. So you can see what the forward power general level is and the frequency range. Steps through. So here we have a lot more steps. We actually could increase the step size a little bit, but we'll get there. So you can see in here, we're going over a much bigger frequency range. So we're seeing the actual curve of the loop, whereas before we were doing much narrower frequency ranges. Now we're coming up to 14, and that's the test. Alright, so save this. To RS 100-3. The 7.5 amps here, 13.56 megahertz with the LS 040-1 loop sensor. We'll put the date in there before, which is 115.2. Oh, actually it's 521.22. And save. So we have that saved. We can go back to test. This time what we can do is actually 5 single shot 13.56 seconds. Here we need a modulation, pulse modulation of 100 kilohertz. Kilohertz, 50% duty cycle. And then coupling device, make sure we got the right one, which again, it automatically selects the last one we just did. And if you go, actually pull that back out, you can see, so the last ones here, the 8 amps per meter and the 65 amps per meter, they're read out, so they won't match up at all. And then the yellow one does work. And we can hit play. And again, your setup would be done here. You wouldn't have the loop sensor in there. You'd have it up to your product that you're testing. And it's done very fast. You can bring these down so you can see the spot test. 1 point. 0.56 megahertz, 7.5 amps. Yeah, that's what I want to save it as. Let me go back here, so everything's run. Have our 30 kilohertz, our 134.2 kilohertz, and our 13.56 kilohertz. There you have it. So basically we've gone through the setup of level setting and then creating the test routines for doing the tests. And once they're created, you have them here all the time and ready to go. Thank you and have a good day.